Okay, I think we should start. Good morning to our audience in the Americas and good afternoon to our audience in Europe. Welcome to this program jointly organized by the Florida chapter of the European American Chamber of Commerce, EACC Florida, and the European Railway Clusters Initiative, ERCI. My name is Christina Slizinska, and I am the Executive Director of EACC Florida. Our mission is simple: to create business opportunities by connecting our members to a strong transatlantic network and by providing timely insight into regulatory, legal, and market developments shaping EU-US business. Access to critical raw materials is no longer just a market issue. It is increasingly shaped by industrial and trade policy, and recent EU-US cooperation announcements on critical minerals make that very clear. Today's discussion, Transatlantic Perspectives on Securing Critical Raw Materials and Components in a Fragmented World, comes at a timely moment. Using the rail and transport supply sector as a case study, we will explore how regulatory, industrial, and market dynamics are reshaping supply chains on both sides of the Atlantic. This program is being recorded and will be made available on ERCI's and EACC's video channels. Please also note that the views expressed by our panelists are their own and may not reflect those of EACC or our members. Although you have seen their bios, allow me to very briefly introduce our speakers. Veronica Elena Bocchi, coordinator of DTECFER and vice president of ERCI, will serve as our moderator today. Sophie Jackson, mechanical engineer at CTAP Rail USA, works on innovation projects on both sides of the Atlantic. Ed Kowaleski, business development executive in smart mobility and ITS, supports transatlantic partnerships and regulatory compliance, including Buy American requirements. Bernard Piet, Managing Director of Logistics in Wallonia, leads strategy and internationalization for the region's transport and logistics cluster. And Dr. Wolfgang Reimer, Managing Director of JKZ in Germany, focuses on innovation and collaboration in mineral raw materials. And now, without further ado, Veronica, the floor is yours.
Thank you very much, Christina, and good afternoon from the European side of the Atlantic. So thank you to our panelists and the audience today. The topic is really strategic, okay, for all of us. And just as introduction, let me just remember that after the wake-up call that COVID-19 gave to global value chains, supply chain resilience, that includes securing access to critical raw materials and critical components, has become a topic that nowadays is covered by daily newspapers and no longer just by business management journals. That's why we are here today. As ERCI, co-organizer of this webinar and coordinator of a European project named Leader 2030, we have examined this issue in depth for the railway sector from a forward-looking perspective, which is not only focusing on what is happening now, but also on what may happen in 5 years' time, particularly with regard to the supplies needed for the railway innovations that Europe is investing in. And the conclusion, my colleagues, is, okay, Houston, we've had a problem here. Threats to the regular flow of supplies and functioning of industrial value chains stem from 2 main sources. Disruptions, which may have various causes and can be temporary, such as extreme weather events, logistics bottlenecks, or export controls. And dependencies, which are more structural in nature, linked to factors that have to do with metals to be mined, the existence of or lack of extraction capabilities, and necessary technological know-how. Today, we will touch some of these aspects aiming to present the different perspectives from both sides of the Atlantic, because while certain challenges are global, the ways in which they are addressed can certainly differ. So this is the opening. So now let's start with the first panelist, Bernard Piet. I have just mentioned among the possible cause of disruptions of supply chains logistics. You are a great expert in logistics. So what are the current trends in, being it a driver, okay, to supply securing? And what are the trends and what are the outlooks? Thank you.
So it is clear that in the last 6 years, and you mentioned the COVID times especially, it is clear that all the supply chain and the global supply chains have been totally put upside down. We have had a succession of events since now 6 years that really put supply chains under pressures. It can be either, we mentioned the COVID, the blockade of the Suez Canal in April April 2021, the war in Ukraine, the rise on oil prices, the crisis also on semiconductors coming from Taiwan, and also the uncertainty which is also created by the White House about the tariffs and the trade between USA and the rest of the world, and also the movements in the Red Sea with the Houthi rebels, which are imposing the ships coming from the Far East to go around Africa to reach Europe. So it is really critical for companies to consider their supply chain and to reconsider, because in the last, I would say, 20 years, as long as the globalization was okay, nobody really cared about how goods were transported around the world. And it was also made possible by the fact that the energy was quite abundant and at an affordable price. Now what we see that the situation is changed, and I think that the uncertainty will become the new normal. It means also that for industrial companies, and especially for SMEs, they really have to reconsider their supply chain and to consider the supply chain activity as a strategic aspect. It means also that supply chain must come in the board. Supply chain must come really at the high level of company company strategies. And one thing which is absolutely necessary now for industrial SMEs is to have a clear view of how the supply chain are organized. You mentioned the dependencies. I think dependencies are really crucial. Dependencies from some certain suppliers, dependencies from certain countries also. There is a new concept which is also emerging in supply chain discussions. We were speaking a lot about nearshoring. We speak also more and more about friendshoring, about localizing activities in companies with stable regimes and with which the relations are also stable and can be considered on the long run. But now we really see a shift, and on this aspect, on top of that, you add the aspect of decarbonization and digitalization, which are absolutely key and crucial. And I think that one of the main thing on which companies should now invest, and especially industrial SMEs, is investing in the visibility of the supply chain, to see what are really the logistics chains on which we are depending, what are our critical suppliers, to consider also alternatives and reconfigure the supply chain so that it can now depend not only from one source, but from different sources. So I think visibility, resilience, and agility will be key issues in the coming months and coming weeks.
Thank you very much, Bernard, for pointing out all these aspects that, of course, mean to all companies to widen their vision and widen their way of operationalizing, processes that till now they have given for granted, and they are not. So thank you for this. Now, Wolfgang Reimer. Let's move from a cause of disruption, logistics, to a cause of long-term dependencies. So why dependencies cannot be solved quickly, hence why there is a need for action.
So, yeah, let's start with the European Union and its overall constitution, identifying why we are not so fast and why actions are needed to improve European framework conditions for more raw material sovereignty. And to achieve it, I have to say with Churchill, I have nothing to offer but blood, toil, tears, and sweat. So let's look back to the past 15 years of the paradigm shift that the European Commission implemented more than 15 years ago when it designated raw materials for the very first time as a societal challenge and placed them on par with other challenges such as climate protection, agriculture, the environment, etc. And in its policy making, the EU remained trapped in its own actions and thinking with regard to strategic response. So let's give you a couple of proofs about this. So first, compared to China, the EU, and I would also say the US, lacked a subtle, long-term strategic geopolitical approach to achieve raw materials sovereignty. Our EU foreign policy is not sufficiently interest-driven, but sometimes tends to be moralistic. Compared to a nation-state, Europe finds it difficult to make the necessary quick decisions, and members of EU Parliament tend to think also sometimes rather anti-industry. That needs to be pointed out. The EU policy, aside others too, here we are not alone, has shown little foresight. Just remember, it was in 1992 when the Chinese leader Deng Xiaoping famously proclaimed, "The Middle East has its oil, China has rare earth." That was in 1992. Europe's raw material dependencies are the result of a deep, long-term structural trends, not short-term accidents. They stem from decades of deindustrialization and mining, metals and chemicals, combined with globalization, offshoring, and deliberate substitution of domestic extraction by imports. And reversing this path is technically possible, but it collides with time to build in mining and processing, with investment cycles, with Europe's own policy and societal constraints. And then we face distinct constraints. First, there is time and financial risk profile of mining and processing. What does it mean? New mines and refineries have very long lead times from exploration to a bankable feasibility study. Permitting, construction, and ramp up often takes 10 to 15 years and not 3 to 5. Most EU projects have not yet reached bankable status, and which is why the first CRMA strategic projects are largely already advanced ones. I think that is a good decision to quickly achieve supply security from domestic resources. The sector is capital intensive with long payback periods and high geological, market and regulatory risk, so investors are cautious. And we have also to keep in mind that the global mining capex has fallen and returns on new projects around 7%, which is unattractive compared to alternatives. We are not alone. We are embedded in a global capital market, and the capital flows to where you can increase your revenues. Then we have very unfavorable framework conditions in the EU. The EU, as you know, is one of the most heavily regulated regions for mining, energy, and industry, with a complex permitting, overlapping legislation, extensive legal recourse for opponents, slow projects dramatically. We have many new acts which might drive raw material security in the right direction: the Circular Economy Action Plan, the Critical Raw Materials Act, potentially perhaps also the Net Zero Industrial Act, with many of them, such as the IED, the Industry Emissions Directive, they pursue laudable Green Deal goals, but industry sees them as adding regulatory complexity and compliance cost in an already tight environment. And the best example is the recently launched European Industrial Emissions Directive that hinders a fast raw material supply from domestic resources and investments. And also the internal market trend, macro trends show this. Look at the deindustrialization and investment weakness. So the macro indicators point to declining competitiveness, loss of market share in chemicals and other EIs, higher energy costs than key competitors, and a widening productivity gap versus, for instance, the US. We can now also a closer look to the foreign direct investment into Europe. Europe by now is a net investor, and the FDI has dramatically fallen, and in some reason also in course of the past year, it was even negative, indicating capital withdrawal. And this is incompatible with the massive investment needed for new mines, but also refineries and recycling plants. And so we are trapped in the global competition and geopolitics. Look at the export restrictions, which are intensely increasing in a multi or mini-lateralistic world. We face more resource nationalism, more strategic stockpiling. These are now central tools of power politics, and the EU has little leverage over these dynamics in the short term. So dependencies created over 30, 40 years cannot be undone in 5. At least the Critical Raw Materials Act and the recently published EU Action Plan are moving in the right direction with strategic stockpiling, purchase of mining properties, which was really an interesting note from the European Commission that they started buying into mining property, expansion of raw materials partnership. And these strategic partnerships and free trade agreements, they have not yet delivered. These instruments we rely on have important weaknesses. Most strategic partnerships are political declaration of intent, not legally binding supply contracts. They improve the diplomatic climate, but do not guarantee volumes or prices. And the implementation is also slow. Partner countries expect concrete investment in mine processing plants, infrastructure skills, and the partnerships look strong on paper, but they have a modest impact on real tonnages delivered to Europe. Because they are also slow. We have not yet signed our partnership with Australia. With Mercosur, it took us 20 years and more. That's too long for a world that is spinning faster and faster.
Thank you.
That is the.
We must switch to the next following panelist. But thank you. For this very insightful, discussion. This helps us understand how difficult it is to try to solve problems that we are experiencing now, when solutions do need so much policy and so much industrial times, to deliver. Now let's move to Sophie Jackson. Let's move to the other side of the Atlantic. So from, let me say, very high-level considerations, so global logistics, global mining, now let's move to specific industrial cases, because when we say critical raw materials needed for innovations, let's be clear, let's be specific. One example that is very interesting is hydrogen, for instance. So among the innovations in transport, where also great efforts are already done to secure, the supply chain of hydrogen. There is this kind of new traction mode, environmental traction mode for trains. So from CETA's perspective, as being a front runner in this field, what are the main advantages and challenges of hydrogen traction, and what pathways, do you see for making this possible in the network, in the rail network of the US? So how to make things happen concretely? Thank you.
Thank you. So the US rail landscape actually presents a really interesting, unique infrastructure gap because it's largely non-electrified. And of course, we can't rely on an entire overhaul of this infrastructure to build the necessary overhead lines that we need to electrify the entire country. Vehicles need to be autonomous in generating their own power. Currently, this is done largely by diesel, but in the last few years, we've seen an emergence of newer technologies such as hydrogen. To give a brief overview of what hydrogen technology is and how we use it on trains, as with any technology, there is a storage. So we can use either traditional gas tanks or more innovatively, recently we're using metal hydrides for increased safety. This hydrogen is released into a fuel cell that converts the hydrogen into electricity with water and heat as a byproduct. The electricity that is produced can then be used to either directly power the electrical motors on the train or can be stored in traction batteries. With this in mind, a really key opportunity for us is the integration of hydrogen vehicles in ports as shunting locomotives. Ports, in a way, can be treated as their own self-supported entity, and the significance of shunting compared to a mainline vehicle is the necessity to create heavy, robust, self-sufficient vehicles. Instead, mainline, we're looking at a very long span of hundreds of miles where we need to create a very complex infrastructure. So for this, ports an ideal environment to pilot such initiative, such as hydrogen. Being such a concentrated logistics center, they support a very high volume of traffic, meaning one single well-placed fueling station can be easily accessible not only to locomotives, but for other transportation methods that operate within the port. So we're talking about trucks and boats. These zones are heavily diesel reliant and therefore heavily polluted, often placed around heavily populated areas as well. For this, switch to hydrogen, even for a small portion of the fleet, can hold a really great impact on the environment. Ports also hold a strategic advantage in where they're positioned, that often there is a lot of space around. To pair a hydrogen refueling station with an on-site electrolyzer powered by renewable energy such as wind power. This means that we can also generate hydrogen in that location and not only transport hydrogen that is being created using other methods, again, increasing the amount of CO2 that is produced. With this, we can create almost a self-refilling refuel station, and we also provide the opportunity to increase the storage capacity for renewable materials. Of course, I'm a mechanical engineer, so from the mechanical standpoint, the transition from diesel to hydrogen is incredibly interesting. We're not simply retrofitting diesel systems as we've done in the past, but instead as CITAV, we're looking very deep into the research and development of every component on the trains. And this includes everything from the fuel cell to the hydrogen storage, and all of the subsystems that are required to support such new technology. Of course, as with all emerging technology, there is still some work to be done with improvements of efficiency of components of the fuel cell. We're always looking to optimize the reuse of byproducts, but we've really seen a great improvement in the technology in the recent years, and these advancements are continuing to grow. Thank you.
Thank you very much, Sophie. So now moving to Ed Kowalewski. Okay, in the US, okay, securing access to critical materials and components is very much rooted in federal policies, which create conditions for to more Buy America. Okay, so how Buy America and the US rail and transit procurement rules shape market access for foreign companies in a vision of nearshoring, friendshoring, and so on. Thank you so much.
Okay, thank you, Veronica. It's a pleasure to share with you some thoughts with European companies and organizations represented here. And yes, another thing we have to pay attention today are some protectionist rules. So like in Europe, you have some protectionist rules. Here in America, there's the Build America, Buy America Act, like they say BABA, or maybe we can say BABA. And I'll explain in high level the current American rules and what they mean for your business and some concrete steps you can take now to do business in the US on railroad projects funded by federal grants. I'm sure that a lot of big European companies are already updated in these cases, and they're and also understanding these rules and doing business good here. But usually for maybe some middle and small companies, European companies, it would be good to understand a little bit more about that. And the reality is that the U.S. market for rail and transit is large and growing, but it is now like a domestic first market. The Buy America, the BABA, on top of the existing Buy American rules, because this started on the 30s, changed how you must approach U.S. procurement if the project is funded by federal grants. So exporting tracks, finished trains, or train sets, or equipment from Europe to serve these projects is increasingly difficult unless you accept local production, local assembly, or strong partnerships. What are the requirements? The Build America Biometric Basics are like this. Transportation projects funded by federal grants must use U.S. produced iron and steel and U.S. manufactured products. So the BABA expanded the scope to construction materials and tightened it to domestic content tests. So, and I will share a little bit about some key numerical thresholds to keep in mind. In mass transit procurements, Buy American applies to projects over about $150,000. And manufactured products, final assembly in the US is required. By October 1st this year, 2026, manufactured products must have a majority over 55% of components manufactured in the US. Talking about rolling stock, like passenger rail cars, generally requires 70% of components by cost to be US produced plus final assembly in the US. There's some waivers because it's a discretional decision for specific agents. But anyway, waivers are limited and only granted in narrow circumstances, like no U.S. source, public interest, or if domestic sourcing would increase projects' cost by over 25%. And about the oversight, compliance is monitored by agencies such as the FRA, the Federal Railroad Administration, and the Made in America Office. And actually, this is not like a Trump administration creation. These rules are signed by Biden administration, so in 2021. What Trump administration did was to maybe to tighten more some specifications and some oversight in this case. So you have to expect rigorous documentation, labeling, and audits. Okay. And what this means for European suppliers? Some practical implications. You will be evaluated on where parts are made, where final assembly occurs, and who supplies key inputs like steel and major subcomponents. So simple cross-border supply or finished product will increasingly fail domestic content tests for these projects. Waivers are increasingly hard to get and should not be considered as a strategy. So, and the most important thing to think is maybe to do some partnerships. As this will be the next question. Thank you, Vernon.
Thanks a lot, Ed, for being so clear and also strategic under, yes, I mean, a cross collaboration, because when problems are global, the only opportunity and possibility is to cooperate. So now let's go back to Bernard Piet. In the meantime, let me say to the audience that if you have any question, you can post it in the chat. Do it by the next 10 minutes. Then we will, use them to prepare the panelists for possible answers. But now, Bernard Piet, again, in the title of this webinar, there is the concept of a fragmented world, and we know what it means. But it is also working this fragmentation as a driver to unblock regulatory obstacles that are also affecting logistics, so that ultimately logistics can benefit from this kind of simplification. Up to you.
Yes, indeed. So I do believe that in the current world that we see, we will see a sort of deglobalization between the different economic blocks around the globe. So I think that considering supply chains, Europe, Asia, and America may be less connected than they were before. One of the points is that companies have sometimes a short memory. And we've seen the dependencies and the problems that I mentioned in my first intervention concerning these global supply chains. And sometimes companies want really to come back to normal as they did before. But I think that's really no longer an option. I think that they really have to think forward. I believe then that, as I mentioned, we will see in the coming month, in the coming year, a sort of not complete deglobalization, but a more fragmented world. Now, there are rules concerning supply chain and logistics, which are applied around the globe. What we can see and what we may see, we see a new role for tariffs also in other parts of the world. Maybe that the supply chain that we've seen in the last years will be less tangible, and the fact that companies will have to reshuffle their supply chain and reconsider the location of their supplier will impose new rules. Are there now regulations necessary? I would say I'm not for protectionism. Will we see in the coming years and the coming months and the coming years more protectionism from the different blocks? It may be an option. It seems so far that that's not the option that the EU is taking. And when you see that EU has made of the free trade one of the, I would say, one of the main driver of its development. Now, this kind of free trade movement has created to some problem also in the industry in Europe. So will we see now a more general set of rules about global logistics? I think it's still difficult to figure it out, but I'm really convinced that the coming month and the coming years will be more fragmented supply chains, more regional supply chains, and that maybe some block of countries will have to collaborate more closely in order to make the supply chain more seamless.
Thank you very much also for this further considerations. Let's go back to Wolfgang Reimer now. So what we have studied together, Wolfgang, is also that if there is a scarcity in some critical materials and some critical components, one of the possible recipes for resilience is substitution. So substitute a material with another one. But what is the situation? What is the actual possibility with that, and what the limits?
Yeah, thank you for that interesting question. So perhaps let's first answer the question, what means in-house substitution? That means trying to reduce external dependencies by redesigning technologies and value chains so that they rely less on scarce or risky inputs, ideally within Europe. Or deliverable shows that substitution has an important role, but also that its potential is often overstated and bounded by technology, economics, and time. So the main substitution recipes relevant to rail and the critical materials are material for material substitution, a functional and design substitution, and system level substitution. So let's look at a few examples for material substitution. So that is replacing one critical raw material with a more abundant or less risky element, e.g. moving from certain rare earths to less critical alloys, or from high cobalt chemistries to lower cobalt or cobalt-free batteries. Shifting magnet technologies, for instance, to optimizing ferrites or using less dysprosium-intensive designs, or moving from gallium arsenide to alternative semiconductor materials where performance allows. Examples for them, functional and design substitutions are redesigning components to use less of a critical material per unit of performance. For instance, lighter structures, improved efficiency, miniaturization of electronics, smarter thermal management, or the design of circularity, standardized components, modularity, and easier disassembly that make future recycling and reuse technically and economically viable. And last, the system level substitution. At system level, rail itself substitutes road and air emissions. With rail, digitalization and better asset management can reduce the total hardware needed for a given service level and indirectly lowering critical materials demand. In some cases, operational optimization can delay replacement or upgrade cycles, again lowering cumulative material needs. And why are these recipes so important but cannot solve the problem entirely? So substitution can soften dependencies, I would say, but it cannot fully offset them, especially not by the time given in the LEADER 2030 project. We targeted 2030. So what are the main limits? First of all, we have technological readiness and performance limits. Many substitutes do not yet match critical materials in key properties, such as energy density, magnetic performance, corrosion behavior, temperature stability, or lifetime. High-stakes applications such as traction systems, safety-critical electronics, or signaling have stringent performance and reliability standards. Qualifying new materials and designs take long R&D and this is important, also certification cycles, often well beyond 2030. And then we have a slow innovation in industrial cycles. Rail and other infrastructure sectors operate with long asset lifetimes and conservative engineering cultures. Changing materials implies redesign, recertification, and new supply chains. And standards, homologation, and liability considerations all slow down the diffusion of substitutions, even when lab-scale results are promising. Then supply and dependency simply shift. Here, an example, alternatives themselves can become critical. For example, sodium-ion batteries need graphite, and alternative magnets may rely on other rare elements. Some green alloys depend on metals with their own supply risk. So substitution may thus change the pattern of dependency rather than eliminating it. And in a tight global market, this can create new bottlenecks. There are also economic and market constraints. New materials and redesigns often come at a higher cost, at least initially. They may require new production lines, new tooling, and new skills, and should be ready for upscaling. And customers may be reluctant to pay for performance that is equal or slightly worse but more expensive. Warranty and reliability concerns are also slow uptake. That is also important to consider. In the end, we have systemic and information bottlenecks. So there might be limited transparency on where and how critical raw materials are used in complex products, which makes it hard even to identify realistic substitution options. Bill of materials and composition data are often proprietary or simply not collected, although the Commission is starting to improve that with introduction of new labels. But we live in a fragmented value chains, and lack of coordination mean that material scientists, component suppliers, and OEMs do not always work in lockstep on substitution strategies. So implications for policy and industry play also in. So substitution must be pursued, but as one pillar alongside domestic mining and refining, recycling, resource efficiency, and diversified international sourcing. Policy can help by funding long-term R&D on substitutes, supporting demonstration and requalification, incentivizing design for circularity and removing regulatory barriers that slow safe innovation. And however, expecting substitution alone to deliver autonomy by 2030 is unrealistic, even under optimistic assumptions. But in the long term, yes, it substantially contributes. And this we can also say for rail. So just to conclude, an in-house substitution offers valuable degrees of freedom and can reduce exposure for specific materials and applications, but it is constrained by physics, engineering, costs, and time. It can buy resilience at the margin, not replace the need for a broader raw material strategy that includes domestic capacity, recycling, but also a smarter international engagement. But it doesn't look that bad. So substitution is one of the main drivers of the European raw materials supply security policy. Thank you.
Thanks to you, Wolfgang. Actually, yes, let me just stress the fact that this current situation, of course, does not affect only the railway sector, but these are kind of headaches that also the automotive has, the energy has, the aerospace has, the defense has. So we are all together, I mean, in this. So
which
thanks again. So moving to Sophie Jackson. Because we mentioned with Wolfgang one possible recipe to scarcity of raw materials and components, and that was a substitution. But with you, I would like to discuss about reduction of the materials needed. And one strategic area for reducing materials use is, for instance, in the revamping and maintenance, okay, where solutions such as additive manufacturing for spare parts and predictive maintenance to optimize life cycle management can be great solutions to be leveraged. So how does CETAV view the strategic role of these solutions, and especially for the US?
Of course, when we discuss any type of revamping, there are many points to look at. So firstly, we can consider one of almost always the most important is the economic aspect. The costs associated with designing and manufacturing a completely new component has extremely high upfront costs. These include research and development, structural design, and ultimately the construction of major components. I speak for trains that we're looking to not continuously produce frames and buggies and wheel sets due to the high impact that they have on the environment due to the quantity of material that is required. With revamping, we have the possibilities to start from a project that is already complete, that has been trialed and tested, it conforms to the standards and has been approved for the environment that it needs to work in. It's also undergone complex testing such as structural integrity, crashworthiness, dynamic performance. All of these things have already been proven. If we take that vehicle and we strip it back to just its core components, and then we build new subsystems on top, we remove large parts of the costs, and not only that, but we also reduce significantly the timescales that are required to reproduce these new components. Secondly, building an entire product from scratch really works against what we're trying to do when we're looking to implement low emission fuel methods. By starting with a new construction, we are increasing life cycle emissions before the vehicle is even in service. Considering that a locomotive frame and wheel set can weigh upwards of 40,000 kilograms. The disposal of these materials is costly and requires even more energy for their melting down. Revamping allows us to utilize these products with the carbon footprint that has already been created, rather than allowing aging diesel locomotives to be scrapped prematurely. Refurbishment supports our circular economy principles. A situation right now that some vehicles have been around for almost 40 years, if not longer, and these vehicles are very well designed. They were designed to be revamped and maintained for an incredibly long time. with proper inspection and maintenance and repairs where necessary. These structural elements often remain mechanically viable well beyond their original expected service period. At a certain stage, these vehicles, they require a comprehensive overhaul to remain aligned with new regulations. This overhaul represents a significant sort of decision point for the user, rather than investing substantial resources into prolonging the life of a high-emission diesel propulsion system. Operators have the opportunity to reassess the traction technology altogether. By replacing outdated and polluting powertrains with lower emission alternatives, the vehicle can be effectively given a second technological life. This allows companies to go ahead of the current norms and put them in a good position, not only to adhere to current emission standards, but also those that will emerge in the near future.
Thank you very much. And now back to Ed Kowalewski. So let's continue with the recipes, and let's continue with the discussion you started earlier. We acknowledge that we cannot solve everything alone. We acknowledge that cooperation is critical, and one of the recipes, as I said, is to work on the territories where the value chains are. So in terms of US-EU collaboration in the railway sector, what can be the strategies for European firms to partner effectively with US prime contractors and win compliant projects?
Yes, yeah, maybe the one of the answers about all these questions is to partner, and this is the main goal of the Chamber of Commerce. So I will share with you my 2 cents of some concrete strategies to win compliant projects in the US. First one, partner with US primes, but partner smart. Form joint ventures, licensed manufacturer, or long-term subcontracting with U.S. prime contractors who already meet federal procurement standards and have established relationships. Actually, this is what is happening right now for the California high-speed rail projects. There's a lot of European companies partnering with U.S. primes. And another thing is structure partnerships so that you provide technology, engineering, and intellectual property while U.S. partners handle final assembly, certifications, and management of domestic content obligations. And a second point is to localize strategically. So not necessarily everything, but the critical items. Prioritize localizing final assembly and the highest cost or hardest to source components that matters in the percentage calculations. So as an example, rolling stock, think truck assemblies, car body fabrication, doors, HVAC, and consider modular manufacturing. So pre-assemble systems in Europe, but set up final assembly lines that incorporate US sourced critical components to meet the percentage. And another point is to redesign and supply chain engineering. So revise your bill of materials and product designs to increase content that can be sourced from US suppliers without degrading performance. Work with US vendors for like plastics, electronics, subframes, wiring, harnesses, and other components that can be reasonable localized. And another point is invest in a compliance program. So create maybe is for this suggestions is more for middle companies. So create a Made in America compliance lead, standard operating procedures, and a document control system for country of origin tracking. Prepare to provide certifications, labeling, and audit trails. Engage third-party verification if needed, and train some bid teams on how costs are located by primes and how component cost breakdowns influence compliance percentage. And finally, use cost and bid strategies. Negotiate with primes on cost allocation methodology, how components and value impacts the percentage tests. Price your U.S. operations to reflect the additional compliance. So in terms of certifications, record keeping costs, and also it's good to understand that you have to record keeping to have a record keeping costs in order to protect your margins, and this is the most important. and finally, I think maybe I would be very happy to share with you some operational steps and risks and pitfalls to avoid, but this may be in another opportunity. So this is what I could share, and as I mentioned before, there's a lot of European companies already partnering with US prime contractors.
Thank you very much, Ed, for this very, clear, actionable suggestions. Now it's time to answer a couple of questions posted in the chat. So I leave the panelists the time to read them and to decide if you want to dig in. From my side, I can start answering with the second one. Where do you see the biggest gaps between European and US approaches, to securing blah, 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 and what practical steps could close these gaps by 2030? Actually, after thorough studies, let me say that US and EU are following the same steps, the same kind of policies. Of course, we are talking about policy level, macro level, because ultimately this possible solutions, you may have creativity, but the possible solutions are the same for everyone throughout the globe. The only difference, let me admit, is in the magnitude, the power of interventions on the US side. Because if we talk about attracting foreign investments to bring in value chains that were no more working in your country, which is some applicable to some parts, for instance, of the semiconductors value chain, the magnitude of the investments to make this happen is absolutely higher than the great efforts that, however, Europe is doing. And this is just one example. Other policies that, actions they are all using is signing commercial, trade agreements with a specific focus on metals, critical raw materials, and so on. But also let me stress that many of these things are done again together, because there are tools, there are, task forces, joint task forces where US, Europe, and also other global players are together to find answers and solutions. Because again, the problem is global. We cannot just think to solve it in-house. In the meantime, do the panelists want to answer, to add more?
Yes.
Wolfgang, please.
I can do. I would say the biggest gaps, because there was also a question about the gaps between the US and Europe, is that Europe has a weaker midstream and refining base, a slower permitting and fragmented funding. There's this very muscular, subsidy-driven domestic first US model, which is not that bad. And to close those gaps by 2030, I would rather talk about a longer term, 2040. Europe would need to accelerate permits for mining, processing, recycling, and to coordinate the risk finance, because finance is one of the most important factors to engage the mining sector in Europe, and also to make sure that we have real offtake guarantees, also around a small set of strategic value chains at least, and of course a tighter, more enforceable diversification and stockpiling rules, which is part of the Critical Commodities Act. I think that is very wise, but it needs to be clever implemented and ideally aligned with North American partners. And I think here we have much in common. And independent of the US tariff policy, the United States and Europe are increasingly uniting their efforts to secure Critical Raw Materials Act needed for those transitions we are speaking about, and rail and special. So they are largely driven by the goal of reducing the reliance on China. Here we have most in common, and strengthening supply chain resilience. So, for instance, we have the Mineral Security Partnership, where the US and Europe are major partners in. We have an EU-US Critical Minerals Agreement, which is important. We most recently have started negotiations about strategic partnerships for critical raw materials, the so-called Forum on Resource Geostrategic Engagement, FORGE. And there are many more, and that is good. That is the binding link between Europe and the US, and that is very much promising.
Thank you very much, Wolfgang. And on the first question about substitution, I mean, how to accelerate. We are very much aware of this problem. Of course, we acknowledge that the railway sector is one of among the most regulated sector for safety reasons, okay, because moving many passengers, but also freight, but above all passengers on trains is unethical, okay, I mean duty, okay, that needs the utmost safety. And of course, each time something is changed in a product, a component, the process must start again. So this is widely acknowledged, and recommendations to not relax, but to simplify this also for resilience needs is on the table. This gives me the opportunity to inform all the audience that within our Leader 2030 project, we are right now running a public consultation on a set of recommendations listing this kind of solutions. Together with the link to the recording of this webinar, we will send you also the link to this document in case you wanted to read it and react on it. I stop here. Up to you, Christina.
Thank you so much. Could I ask all of the speakers to turn on their cameras again so that we can properly thank them and they can be visible while we do so? So I would like to extend my warmest thanks to our moderator, Veronica, and to our panelists. Whoops, sorry, I lost my text. To our panelists, Sophie, Bernard, Ed, and Wolfgang, for an insightful and substantive discussion. I would also like to thank Lutz Hübner from Technical Host ERCI Cluster in Berlin for what was a truly seamless technical support. Today's conversation clearly demonstrated that critical raw materials, supply chains, and regulatory alignment are central to the future of the transatlantic industrial base. It also showed that access to the US market continues being desirable, but has become more complicated and protectionist. This underlines the importance for companies in Europe and elsewhere to work with the right service providers and partners here in the United States, who hopefully will be part of your success story in this country. If you have follow-up questions or would like to learn more about ERCI or EACC Florida, please reach out to us. We'll be happy to continue the conversation. As a reminder, the program has been recorded and will be made available on our respective video channels. Again, thank you so much, all of you, for joining us. Thank you so much to the ERCI for partnering with EACC Florida, and we look forward to seeing you all in a future program. Bye-bye.
Thanks to you.